Okay, today we're looking at horizontal projectiles. Remember that horizontal motion is completely independent of vertical motion. So at any time, the horizontal motion is going to be constant across, and we can analyze that motion completely separate from the object falling. So we saw that in the last video, and we put these two motions together, and we end up with this projectile motion that's sort of a combination of the two motions happening at the same time, and we have this parabolic path. So the horizontal motion is independent of the vertical motion. We're accelerating this way, and we have no acceleration in this direction. So no acceleration this way, constant speed horizontally. We're accelerating due to gravity vertically. So let's take a look at some examples and see how I tackle them, and I recommend that you tackle them also. So with that, let's take a look at a marble that rolls across the table, and I'm just going to say here's my table, and this table is 2 meters high. So distance in the y direction is 2 meters. It's moving horizontally at 5 meters per second, and it will come off the table, sort of make this path and hit the ground down here. And what I want to know is, what is this distance here? What is this horizontal dx? So I suggest making a table to separate those two motions, horizontal and vertical. Remember, x is horizontal, so you might want to put horizontal there and vertical here in terms of identifying those motions. So what do we know in the x direction? Well, we know that its speed coming off the table is 5 meters per second. I want to know the distance. And remember, since we have no acceleration in the x direction, we're sort of going to be looking at d equals tv over here in the x. So if we could find the time, we could calculate what that distance would be. So let's take and identify what we know in the y direction. Well, in the y direction, as it's rolling across the table, it's not going up and down, so therefore its speed vertically is 0. We know that it's 2 meters off of the table, and since it's measured down from the table, we're using a negative to indicate downwards. The acceleration is due to gravity, so that is equal to, I'm going to use 10 meters per second squared for gravity. Recognize you can use 9.8 as well. And can we find the time in the y? So we have all of those pieces of information, and if you recall, we can if we go back to the d is equal to vit plus the 1/2 at squared. Remember that your initial speed is 0, so the distance is 1/2 at squared. If we use our algebra skills to solve for t, I'll do this one step at a time. We have multiply through by 2, we have 2d is equal to at squared. Divide through by the a, so we have t squared is equal to 2d over a. And then if we take the square root, we have the square root of 2d over a is equal to t. So if we substitute those values in, we have the square root of 2 times our distance of a -2 divided by gravity of a -10. Notice the double negatives will cancel. So if you end up with an error in here, you probably lost a negative somewhere up here in your data. So remember, a negative divided by negative is a positive, so that you can take the square root of that, and you should come up with 4 divided by 10. Square root is 0.63, 0.63 seconds. So that's the time it takes to hit the floor. So at the same time that it's falling, it is moving horizontally, so we can move that t over into the x column, 0.63 seconds. So then distance is equal to tv. So t times 0.63 times 5 gives us a distance of 3.2 meters. And that's what we were looking for. Recognize that if we want to find the resultant velocity as it hits the ground, the velocity horizontally doesn't change, so this is still 5. And the velocity in the y direction then would be at plus the initial speed, which we said was 0. So it becomes 10 times the 0.63, or 0 I'm sorry, 6.3, get rid of that, 6.3 meters per second vertically. So we could then use the Pythagorean theorem so that the resultant velocity would be 5 squared plus the 6.3 squared square root. And if we do that, 25 times 25 plus 6.3 squared, and then take the square root, we end up with 25. I don't think that worked. 25 plus 6.3 squared. It's 65. Square root of 65 puts us at 8. So this resultant is 8 meters per second. And then the angle is tan inverse of y over x, which is 6.3 over 5. And if we do that, I get 51 degrees, 51.5 degrees. So that would be the resultant velocity as it hits the ground. And this angle is with the horizontal. Okay, so, and that would be that. So this sort of finds everything that you'd want to know about that projectile. So let's take a look at another problem. So example number 2, we have a child throwing a stone off of a cliff. So here's our stone, you know, hand going back there, boom, there's our stone coming off this way. So that's our velocity. Here's our cliff. And that stone comes down here and lands somewhere over here. So the information that we are given is that this cliff is 50 meters high, so D is equal to 50 meters. And it lands and makes a splash over here in the ocean at 40 meters away. So again, start off the same way. Find, set up your XY table. And then separate your motions and what you know. I want the velocity, so I don't have that to list. I know that my horizontal distance in the x direction is 40 meters. I don't have any other information in the x, so I come over to the y. My v initial is going horizontal, so my speed horizontally or vertically is 0. My height is a minus 50 meters. The acceleration due to gravity is a minus 10 meters per second squared. And again, I want the time. From the last example, we saw that time is equal to the square root of 2d over a, so I'm going to jump right to that. So t is equal to the square root of 2 times distance of a minus 50 divided by gravity, a minus 10. So I end up with 2 times 50, which is 100, divided by 10, which is 10. And if I take the square root of that, I get 3.16 seconds. So that's my time. I can now move that time over onto the x side, 3.16 seconds. And now I can find that velocity that I was looking for as v is equal to distance divided by time. So d is equal to 40 divided by 3.16 seconds. And 40 divided by 3.16 gives me 12.6 meters per second. So that launching velocity horizontally is 12.6 meters per second. So there it is. Practice a couple of these, go back through them, work these to make sure that you can recreate this type of problem. Again, we can solve for anything. I could have not given you the height, and we could have gone through the same procedure, except then we would have just solved for the height after we had found that time. And in that case, we would have found the time in the x column. Okay, so good luck with some of these, and we'll do more in class.